missed being with you yesterday, but I felt well enough to record a lesson for you. Obviously, I know it's not as good as being in here in person, but at least we're not falling behind. So, hey, you kind of get to experience what Gavin and Brecken are experiencing, and that's having to watch me by way of video. The difference is they get to hear your voices normally, and today it's just all me. So anyway, I want you, if you would, for just a moment, before we take a look at your homework, I want you to, in your notes, go and get down 3 functions. I want you to get down f of x, 3x squared negative 5, a function we'll call g of x, which will be x squared positive x, and a function h of x, which will be simply x negative 4. We had talked about combining functions through addition, subtraction, multiplication, and division in our last lesson. We'd also talked about evaluating these. So for instance, if I wanted f minus g over h of 7, we said what we could do is we could subtract the g function from the f function, get that value, divide out the h function, then plug a 7 in. And I said, why? Why would we do that? The easier way is find f of 7, find g of 7, find h of 7, subtract, divide. At your seats, I want you to do that. Then I also want you to find fh plus g of negative 2. Go ahead and pause the video while you work on these, and then we'll take a look at them once you're finished. All right, well, let's go ahead and see how we did on these. For starters, we should have found f of 7, first of all, to be, let's see, that's 49 times 3, 147 minus 5, I'm getting 142, and I think I'll fact check myself because my brain may h of 7 to be 3, so I'll have to take the 142 minus the 56, we'll divide it by 3, and now it gives you a decimal, right? 28.6 repeating, that's 28 and 2/3, or you could say 28.6 repeating, and there we go for f minus g of h. At least I think that's what you get. It seems like a weird number, but whatever. All right, then for fh plus g of negative 2. Well, that means we need to start by finding f of negative 2, and that'll be 7. We need to find g of negative 2, and that'll be 2. And we need to find h of negative 2, and that'll be negative 6. So fh means we're going to multiply those first to get negative 42. Then we're going to add the g of negative 2. And we're getting a much better answer this time. Comes out evenly to an integer, negative 40. So trust you got those answers there. I suppose if you have questions, you can pause the video for just a moment, and someone who got it correct could maybe explain something further, but I think it's pretty self-explanatory. I want you to take a look at your homework now. If you would, please open your books to page 192. Page 192. And here we practice not with evaluation of the functions, but simply with the combining of the functions through addition, subtraction, multiplication, and so you're going to add f plus g of x. And so when you add the f and the g together, well, combine your like terms, you're going to get a negative x squared, a negative 2x, and a positive 9. Negative x squared, negative 2x, positive 9 is your answer for f plus g of x. Number 4, when you find f plus g of x, we're going to get a 3x squared, negative 4x, negative 14. And literally you're adding polynomials is all you're doing here. So I trust we got numbers. Then go back to adding, right? F plus g of x. End up with a negative x squared, negative 8x, positive 14. Again, f minus g of x is negative x squared, negative 8x, positive 14. Number 8, again, add the inverse of the g of x. Then when you combine your like terms, you end up with a positive 3x cubed. We're going to take the negative x squared, negative 5x, positive 1, and multiply it by a negative 8x, positive 5. Again, you almost wish you had numbers you could evaluate and just multiply the numbers together. I'm going to double distribute this way. I'm going to distribute the negative 8x to get a positive 8x cubed, positive 40x squared, negative 8x. Then we'll distribute the 5 all the way through. You get a negative 5x squared, negative 25x, positive 5. Your answer then should be 8x cubed, positive 35x squared, negative 33x, positive 5. Number 12. It's okay, you can't get terms through a video. At least I don't think you can. Number 12. Should have ended up with negative 42x to the 4th, negative 33x cubed, positive 6x squared, positive 267x, and positive 378. So nice big long answer there. Again, negative 42x to the fourth, negative 33x cubed, positive 6x squared, positive 267x, positive 378. Curious how many of you had that answer correct. Just required some stick-to-itiveness. For number 14, we're finding f over g of x, and I can get this gloppiness out of my throat. And so we're taking the x squared positive 11x positive 18, we're dividing it all by an x positive 2. Could you use synthetic division? Sure, you could. I'd rather say x plus 2x plus 9. Factor it, cancel away the x plus 2's, and say that my answer is simply x plus 9, so long as x doesn't equal a negative 2. And that would be my answer for number 14. Number 16, kind of a weird one because of the way the factoring works. You're going to take the f function, and because it has a leading negative, when we factor the x squared, we could pull out the negative up front all over the g of x function, which was x positive 2. So you could say that f over g of x is negative quantity x negative 17 or negative x positive 17, so long as x doesn't equal negative 2 again. How about that? Okay. For a minute I was wondering if I copied something wrong, but that is our answer there for number 16. Hopefully you got most of those correct. If not, well, hopefully tomorrow I'll be back. I can answer more questions for you. We need to move on, though, to our next section. That is composition of functions. Composition of functions. Next section in your notes. Combining functions keeps the functions separate. Composition of functions takes one function and puts it inside another. For instance, write this in your notes if you would, please. If I've got an f of x is 3x negative 4, if I've got g of x equals x squared minus 1, meaning in the g function, in here for the x, I'm going to plug in the binomial 3x of x. It means the same thing, okay? So g of f of x or g of f of x. I actually prefer this notation. I think it's more